Around 300 million years ago, up to 70% of some coal beds on Earth wasn't wood. It was charcoal. One group of trees had turned the air itself into something that could catch fire almost on contact. For 60 million years, the forests kept burning. They also kept growing back. Before this, wildfire on Earth was nearly impossible. Land plants had only recently spread across the continents. The atmosphere still held roughly today's oxygen concentration, about 21%. Then, lycopsid trees like Lepidodendron rose out of the swamps of what would become Europe and North America. Some grew past 30 meters. For the first time, forests covered the land in continuous, unbroken belts, and the equation for fire on Earth had permanently changed. Coal seams pulled from the Illinois Basin, dated to around 309 million years ago, held something strange in their layers: charcoal. In some samples, almost nothing else. Fossilized giant dragonflies from what is now Commentry, France, told the same story from another angle. Wingspans over 60 centimeters, on insects that could only have breathed an atmosphere richer in oxygen than our own. Models of the Carboniferous atmosphere put oxygen levels as high as 30 to 35%, compared with 21% today. At that concentration, almost anything can ignite, and once it does, it burns hotter and spreads faster. Every lightning strike across those coal forests carried the potential to become a wildfire. The charcoal record shows that many of them did. Again and again, for tens of millions of years. For decades, the standard explanation was simple: nothing could break the wood down yet. Fungi capable of digesting lignin, the theory went, hadn't evolved. Fossil and genetic evidence has since overturned that. Lignin-degrading fungi already existed before the Carboniferous began. The real driver was geography. As the supercontinent Pangaea assembled, vast, low-lying, waterlogged basins formed along the equator, and plant material sank into them faster than it could decay. Fire or no fire. Wildfire added its own layer on top, sealing charcoal into the same wet ground before it could burn away completely. That balance held for roughly 60 million years. Then the climate turned against the coal forests. Around 305 million years ago, a new ice age began cooling and drying the tropics. The wetlands Lepidodendron depended on shrank into isolated pockets. Within a few million years, most of these towering trees were gone, replaced by ferns and early conifers built for a drier world. The coal formed in those burning, waterlogged forests still powers much of the modern world. Buried carbon from an atmosphere no human has ever breathed. The fire regime that shaped it hasn't disappeared either. Scientists studying the limits of modern wildfire still use the Carboniferous as their baseline for how much oxygen a forest can survive. The trees are gone. The fire they made possible is still being studied to understand our own.